Okay, 6.3 is medians and altitudes. So the first thing that we're going to talk about is the median of a triangle, and it is the segment from a vertex to the midpoint of the opposite sides. Okay, so as a note, the three medians are concurrent, meaning that they're all going to cross at the same point. Okay, and that point where they all meet is called the centroid. So it's the point of concurrency of the three medians. Okay, and this one will again always be inside of a triangle. Okay, theorem 6.7 is the centroid theorem. So it says that a centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay, so if we're looking over here at this triangle, okay, yep, you were able to see all of that. Okay, so if I'm looking over here, the medians of triangle ABC all meet at point P. So that tells us then that AP is 2/3 of the whole thing, which is AE. And then I would have BP is 2/3 of BF, and CP is 2/3 of the entire thing, which would be CD. Okay, so using that now, it says in example 1, in triangle RST, point Q is the centroid and SQ is equal to 8. Find QW and SW. Okay, so I know that SQ is 2/3 of the whole segment, which would be SW. Okay, so I know that 8 is equal to 2/3 of SW. So then to get the answer, I would multiply by the reciprocal, which would be 3/2. Okay, so I'm going to multiply by 3/2 on both sides, which means I'm going to multiply by 3 and divide by 2. So 8 times 3 is 24, divided by 2 is 12, is equal to SW. Okay, if you're just going to simply divide by 2/3, then you have to use parentheses on a calculator or you're going to get the wrong answer. Okay, so from there I solved for SW. So then to find QW, well, QW is equal to SW minus SQ. So that would be 12 minus 8, which is 4. You could also do that by taking 1/3 of 12, which would be 4. Okay, because this is 2/3, so that means the smaller portion would have to be 1/3. Okay, so in example 2, okay, it says to find the coordinates of the centroid of triangle RST with vertices of R at 2, 1. Oh, you know what? I'm actually going to count by 2's here. So here's 2, 1. There's R. S is at 5, 8. Okay, so that would be in the middle here. So 2, 4, 5, 8 is 2, 4, 6, 8. S and T is at 8, 3, so 2, 4, 6, 8. 3 is going to be in the middle here. Okay, so there's T. So ignore that other point that I put in there on accident. Maybe I kind of tried to cover it up there. All right, so here's my triangle. So step 1, we graphed it. Graph triangle RST. Okay, then in step 2, we are going to find the midpoint of RT. Okay, so that would be R to T would be 5, or sorry, R to T is 2 and 8. 2 plus 8 divided by 2, and then 1 plus 3 divided by 2. So the midpoint is at 5, 2. So 2, 4, 5, 2 is right here. Okay, that's the midpoint. So then step 3, we are going to find centroid. And to do that, we are going to find the distance first. So distance from S, which is at 5, 8, to the midpoint M, which is at 5, 2. Okay, because these both share the same number in the X spot, I can just take 8 minus 2 to find the distance. If these did not share the same value, I would need to do the distance formula, okay? So refer back to another chapter if you need the distance formula. Let me know if you don't remember it when you're going to do your assignment, whatever you need. Okay, so this one is 6 units. So the centroid, we know, is 2/3 of that. So that is 4 units down from vertex S on segment SM. Okay, so that means then that the centroid is at P, which is at 5, comma. I started at 8 and I'm taking away 4. So that means that P is at 5, comma 4 is your final answer. Okay. That one won't be as important to know, but it is important that you practice doing them. Okay. All right. So moving on then. Okay, using the altitude of a triangle now. So the altitude of a triangle is the perpendicular segment from a vertex to the opposite side or to the line that contains the opposite side. Okay, that'll make sense in just a second. Okay. All right, so looking at this, then an extra note, I kind of ran out of room. The 3 altitudes are concurrent, meaning they're all going to cross at the same point, and that makes my orthocenter. So the orthocenter is the point of concurrency of 3 altitudes. Okay, so you can see here if I come from A and I go across and make a right angle, come from B to the other side to make a right angle, come from C to the opposite side to make a right angle, that is called an altitude. Then the point where those all cross is called the orthocenter. Okay, so as shown below, the location of orthocenter P of a triangle depends on the type of triangle. So if you have an acute triangle, It is P is inside the triangle. If you have a right triangle, P is on the triangle. Okay, because an extra note here that the legs are also altitudes. Okay, because they obviously come and make the right angle, come and make the right angle. Okay, and so then on an obtuse triangle, you see that I have to extend these sides, okay, for some of these to work. So you can see that there. So in this case, P is outside the triangle because we had to extend altitudes. Okay. All right, so then we can turn the page here. Find the coordinates of the orthocenter of triangle XYZ with the vertices of X at -5, -1. -1 is X, Y is at -2, comma, +4. And Z is at +3, -1. Okay, so step 1 is that we graph it. So let me write that kind of small here. So we graph triangle XYZ. Step 2, I have to kind of squeeze this. I kind of left a smaller amount of room here. We are going to find equation of the line that contains the altitude from Y to segment XZ. Okay, so since XZ is horizontal, the altitude is vertical. The line that contains the altitude is, or sorry, not is, passes through Y, which is at -2, 4. So the equation is X equals -2. Step 3 is going to be find equation of line that contains altitude. Okay, we need another one. So first we're going to find the slope. Okay, so we're going to find the slope of XY. So I'm going to do little x, little y, so you know which one I'm referring to here. So it's going to be -4, sorry, no, -1 minus 4. Sorry, -1 minus 4 over 3 minus -2 becomes +2. So that gives me a -5 over 5, which is equal to -1. So then we want the negative reciprocal of that, because I want it to be perpendicular and make that right angle. So that would be 1, and we know that it needs to pass through X, which is at -5, -1. Okay, so we would do 1 minus -1 becomes +1 equals my slope is positive 1 times x minus my x value is negative 5, so that becomes positive 5. So I get y plus 1 equals x plus 5, and y is equal to x plus 4. Okay, so then step 4 is to find the intersection of x equals negative 2 and y equals x plus 4. So all you have to do is plug in negative 2. You know that the x value is going to be negative 2, so we just got to figure out where y is. So I'm going to do y equals negative 2 plus 4, which is equal to positive 2. So then the orthocenter is at negative 2, 2. Okay, so this was the line that we found earlier, and it's going to be at negative 2, positive 2. So this is P, my orthocenter. Okay, all right, so kind of now to summarize everything that we've done so far in chapter 3, we have this table here. Okay, so here is a perpendicular bisector. Okay, it's cutting the segment in half and it's meeting it at a 90-degree angle. When you have 3 of those, the point of concurrency is called the circumcenter. Okay, and we know that the circumcenter P is equidistant from the vertices. Okay, and you can see that in this picture right here. Okay, all right, the next one is the angle bisector. When you have 3 of those, they meet and it's called the incenter. The point of concurrency is called the incenter. And we know that the incenter I is equidistant from the sides. Okay, you can see that there. The next one is median. When you have 3 medians, they all cross and make the centroid. And we know that the centroid is 2/3 of the whole distance. So I'm just going to use BR here as an example. So I can say BR is equal to 2/3 of BD. Or you can say AR is 2/3 of A. Of course, that one's not. We're just going to go, we're going to make this E. I'm going to make this one F. So AE. And CR is equal to 2/3 of CF. Okay, and the last one here is altitude. Okay, when 3 altitudes are done, they are called the orthocenter. Okay, there is nothing that we need to know about the orthocenter. Okay, so just fill this one in with NA and it shows them how they're all made right here, and that's about it. Okay, there's no rule that we learned from the altitudes or the orthocenter. Okay, so that should be everything then that you need for 6.3 and your quiz. So let me know if you have any questions. Go ahead and get started.